So my dad has like a bunch of weird phrases, and one of them is like, "There's more than one way to skin a cat," and I don't know if that's like a normal phrase. Probably not. Maybe it is. But I interpret it as there's more than one way to solve a problem. And the problems that I've been solving recently have been, or in the past, have been like a lot of kind of like boring business application problems, like lots of forms, lots of buttons, lots of those status fields, and so what I wanted, but like what I haven't seen too much of is other ways to implement those kinds of uh, applications that isn't CRUD. So like we create, read, update, delete. We use Ecto, we use Phoenix, we might use the generators. It's insanely productive. It's very effective. Everybody uses Postgres, and it's just it's just like the standard way of doing things, and that's the thing you can find documentation, examples, example applications. Everything is CRUD, and that's not necessarily a bad thing. And so what I wanted to do is I wanted to first let's like see like what kind of like trade-offs we might consider whenever we're implementing like some kind of business application, and we're trying to decide like what kind of architecture are we going to use. Are we going to use like something more cutting edge like CQRS and event sourcing, or are we going to use something like OTP directly, or are we just going to use Phoenix and CRUD and get it out the door? And what, like, as things change down the line, what are we going to run into? Like, what kind of problems do you see? And then I'm going to show some code for one, like kind of an OTP implementation of more or less this business workflow from Solar. And I tried to pick the most boring workflow I could out of there, and that's submitting permits to a city and then having somebody and letting somebody track it. And so normally it's just a table, like some kind of schema, like in Ecto, and you've got a status field. You got notes, timestamps, and relationships, and that's like it. You have like if I actually bothered to finish the CRUD application, I could show you like what I change set, push it into a repo insert, but that's, I don't know, so standard. I kind of assume you can find that on Phoenix documentation, Ecto documentation, or pretty much anywhere. So one thing I like to do whenever I'm doing whenever I'm like modeling out a new business workflow is I'll do something called event storming. And normally you get people in the room. In my case, I'm mostly just in my basement doing it myself on the computer. But what I'll do is you'll find you define left to right the events that need to occur in the system. Events being past tense, like facts that have happened. And so in this case, like we require a permit, it gets submitted, it gets approved or rejected. If we start adding in commands, it might look like we might put in something like a permit aggregate, and we'll add the actual like imperative commands, and these might be something that'll map to like a form or some kind of form object. Some kind of validation happens on these blue cards, and I've got some of these little tags for like who's doing it. Okay, let's see, do I want to look at anything else on the slides? No. Okay, so let's look at some code. So there is like an example repo, if you can see this. It's just called Many Ways to Workflow. If you want to look at some of this, we're going to look at this OP OTP application. Let's see. Let's zoom in. And so the first thing is that we have some kind of boundary for our system, and this is where we're going to send commands, and this is more or less what our Phoenix application is going to talk to. So at the start of the life cycle, we're not doing much. We're just we're validating it through some other module, and in this case, it's just an embedded schema, and we're pushing it through some change sets, and we have a little bit of an option through this new function to expose it as a form or not, and that's helpful so that you can so that you can say, like, it's kind of the same as having a change function where you're just kind of exposing the validation change set to Phoenix so that you can pull in like, that's the wrong format of your email kind of information. Okay. So I should have drawn some diagrams for what this looks like, but we can look at Observer. So more or less, we have commands and they get fed into our model, and we'll output side effects. So let's see. The actual state machine of the permit is just like a vanilla Elixir struct, and I've seen variations of this, but we're more or less just enforcing some kind of a state machine in a struct with some functions. So we have some rules that tell us okay or error, and then we have some state transitions that push us through the different statuses and make some side effects into the struct. And so this is kind of this more or less is just our functional core, and then we can move into this is kind of where the more interesting things are happening. And so what we're doing at runtime is we're grabbing raw parameters, we're validating them, and then we're pushing them into some kind of runtime process. It's just, in this case, it's just a Genserver, and we're telling it to handle the command. The actual Genserver is what we use to hold state, and it's going to be dynamically it's using Dynamic Supervisor and Registry to spin up this Genserver as needed. So there's kind of, and ask questions if there's something that isn't clear. It's hard to pick this apart and kind of show piece by piece in a good order. So there's one thing up here, it says the restart is transient, and so what that means is that at the end of each callback in our Genserver, we're putting in a default timeout, and that basically means that if nothing happens, if we don't push any sort of messages to this Genserver, it's just going to kill itself after 30 minutes. And so we don't want to hold any unnecessary state, so it's just kind of it's sort of a caching strategy for how we hold on to these processes.
Why 30 minutes?
It's arbitrary,
Okay.
really. And maybe that's the sort of, this is this actual timeout is something that you'd pass into the initialization, and you can kind of configure it. So there's at least, maybe it's time to pull up the Observer. Okay, so this is at least what our supervision tree looks like. So we'll notice that we have under our actual application we have some Phoenix pub sub, and that's just automatic, and that's what most of this is. And then we have our permit supervisor. This is our dynamic supervisor, and then we have our registry. And the registry's job is to basically hide the PIDs from anything and everything else. The PID, the Genserver, that's an implementation detail that if we have some Phoenix Live View application, it shouldn't have to know some PID of a process that's on, you know, some node. It could be on a completely. It's just it's too much. It shouldn't even expose that sort of information. So, and that's more or less, and that's what this. So maybe I'll pull up the application.
Okay, can you
Yeah.
go back one? Just gonna explain something.
Sure.
So like right there on line 29 and 30. So if you haven't worked with the registry before, they're super cool. And so like what he's doing is he's saying, if you're trying to find a particular gen server because they're dynamically being created, he's saying you can find it using this tuple that says it's a via, like through, registry as the module, the name of the code that's actually implementing it. And is that the name of the registry?
Yeah.
The workflow registry. And then the ID, the way to get back to this particular gen server is that last tuple, where it's a tuple and the underscore module and a permit ID. So it will create a gen server for every permit ID. So, and it'll hold on to that and cache it in memory, and so long as it's being actively used, it'll stay alive. And then otherwise it'll kill itself.
Pretty much.
So just that you can do that. So like the idea is you can every process has an ID, like a PID, process ID, and but because it's supervised, you don't want to have to know that ID, because if something crashed and it got restarted, the ID is going to change. So you want to be able to have a more reliable, addressable way of talking to this gen server. And so that's what the registry is letting you do.
Yeah, and more or less, like we basically just want to communicate to our business logic that's happening in the context just with a permit ID. Like we only want to say, hey, for this permit ID, I want to execute this command. And you don't want to have to say like, you don't want to have to write spawn. You don't want to have to like spawn a process and then check, because that should be like automated and completely hidden away from us. And so
the permit ID stays consistent,
yes.
and it just maps to whatever the PID is at the time through the registry.
Yeah, so the registry is it's kind of just like a key value store, and it's just fast and knows how to do that. Yeah.
Cool.
So the actual dynamic supervisor, and you can actually write dynamic supervisors without a module, and it's pretty handy. But like I think it confuses people sometimes because it's like, where is this dynamic supervisor coming from? There's no module for it. So I just wrote it out, and I didn't really need one. So the main thing is that at application startup we create this workflow registry, and this sets up some ETS tables. That under the hood it's doing some ETS tables if it's local only, and then we're starting up the permit supervisor, and this is our dynamic supervisor that basically its job is whenever we need to start up a new gen server process, it's just going to say, okay, I have a new child now, and it's just like somebody who adopts children at will. That's pretty much what dynamic supervisors do. Dynamic supervisors are really nice because like the old way, it didn't like make sense, and like your classic supervisor and like the different restart strategy, it's very good for like static topologies, like where you kind of know in advance like what processes are going to be spawned at startup and how it's going to look. And dynamic supervisor is good for whenever you need things ad hoc, and whenever you need something to happen and you don't know when. It's just whenever somebody presses a button. Okay. Let me see what else. So let's go back to the permit process. And the only kind of requirement dynamic supervisor has is that child process define a child spec, and this is mostly just it's kind of boilerplate that comes with OTP, and like I don't know any of this by memory. I just have a bunch of projects and I copy paste like the top part of my gen server and I put it around, and I just like change the, now it's a design ID instead of a permit ID and stuff like that. So it's not something that anybody expects anybody to remember is just, so the main thing is that our Genserver gives us a bunch of kind of like mount points in the life cycle to set up our state, fetch old state, so you can kind of like figure out what's going on. And so we have a few, like, we kind of expose how we start this process just with like a vanilla function, and all that does is delegate down to our dynamic supervisor and do its default thing to start the process. And this is kind of a convention that you'll see a lot, is hiding the OTP API behind something specific, behind their own functions. Okay, so I've got a few comments here, but the init, we're not actually doing anything, and that's because we didn't really have to. So in the init, this is whenever you'll generally set up some kind of default state, and the kind of a important thing about this code is that it's got this continue init tuple at the bottom. You don't have to do a, all this does is go down to our handle continue. And the reason we're doing this is because we want in our handle continue callback to do expensive work. So what happens at startup is we're making, whenever we say IEX-S mix, we're going up the process and we're starting each process one by one. And during that process, there's you don't want to have like a long, expensive blocking operation to happen. And init will block until it's done. And so if you're doing something like fetching state from a database and it takes 20 years because it's an ancient database or something like that, you don't want to have that happen, at least in your init. And so I don't know, when was it? A recent OTP version, the last 2 or 3 years, they added the handle continue callback, and that basically lets you go through the init process. Your supervision tree can continue starting up, and then your handle continue is going to be guaranteed to be the first thing that you do next. So, yeah, sure.
Is handle continue basically like doing, what is it, like you spawn a process because you know you're going to do something expensive, you can send a message to the gen server that you're in and then do that expensive thing there. Is that the same idea?
Yeah, although I think if you're spawning a process, like so if you have a gen server and then under that gen server you have some other child processes that get started up with it, that's something that you might do in the init because it's probably lightweight unless those processes themselves are doing some work in their init, if that makes sense. So init is like blocking it has to finish for each spawn, and then handle continue is just always the next thing. And so in fact, like we could look at, maybe this is a better example. This is another application that's using some similar things, which has a lot more work in it. Let's see, session process. Oh, actually, this is completely the wrong context. Chat. Query. Cache. Okay. So this is an ets cache, and I'm not going to go into it too much, but in the init we're setting up our ets tables, and so ets is a key value store, super fast. It's just dropping down to C, and so whenever we want some mutable state, we're going to use ets. And so like a good candidate for the init is to start your ets tables and then put the references in your like Genserver state. And then in your handle continue, you'll do things like fetch from the database and then cache and then schedule some sort of a timeout. And so like I'm pretty sure like most just handwritten Genserver ets caches are the init and the handle continue are mostly going to look just like this. It's some minor variations.
So can I just, because you haven't clarified this part, I don't think you say it.
Yeah.
the supervisor is what's blocked until the child's init process returns, right? So if you try to, so if the supervisor itself is blocking starting up a child, you can't, look up a different child using that supervisor by their name, or send a kill, or like those supervisory things are what's blocked. And so that's why you don't ever want to block on the child init.
Yeah. So if you have hundreds of processes that are, and maybe your supervision tree crashes, like something happens in your application and you want it to get up fast. If you have some expensive operation and you basically have like thousands of child processes that have to get started up with that startup procedure, it's going to have to go through the blocking init, and it's kind of, you're going to have thundering herd problems, and you could run into problems that way. And so it's just pushing it over to handle continue is just a good way to avoid things like that. Yeah. And that's kind of like one important point to dynamically supervised gen servers, or maybe just gen servers in general, is like use the handle continue. And I'm cheating with this query module. It's not actually doing anything. I'm going to delegate it to like some ecto thing eventually, but kind of the other thing is that I'm just doing a few things like wrapping commands. So all of our actual interface layer, it's just saying handle command and like delegating to the process. And so we have one problem, is that this process isn't guaranteed to start. It might not be alive. So how are we going to have it handle a command? And so what I did is we wrapped the handling of a command through this function down here, and all it does is talk to our permit supervisor that knows how to talk to the registry, and it says, hey, is there a process already for this permit ID? And so if we go to our permit supervisor, it's just basically saying, find my permits process, and it's using the same via tuple, genserver where is, and we have some other kind of similar helper functions here. And if it's not already alive, we're just going to start it up, and then we're going to give it the command. And that's kind of why the handle continue is important, is because if we've already like preceded some state and the process timed out, we need that handle continue to be like the next thing that happens after the startup. So you could kind of imagine that there's a race condition where you initialize your process, and we only have the permit ID. We don't have the full module struct that we fetched from the database, and so we can start it up in the handle continue, and it's like guaranteed to be the next message. And so like that, I don't know, as far as like the things that were difficult for me to like figure out by myself, and like reading all the documentation and putting together, like figuring out basically just the init, the handle continue, and like how to restart this process and find it through the registry, is like once you like at least know how to do that, you can kind of do any of this kind of business logic stuff with a gen server. And our handle calls are pretty straightforward. I mean, we're just handling some message. At least in this initial one, we're just creating a new permit. We're just consuming the API of our module. We're not actually. We could have some other OTP construct, and it could, we could have a different runtime implementation almost. We could put it behind a behavior, and it would just use the permit API in the same way. And that's helpful, because if you don't want to have to make changes to all of this gen server code whenever you want to change your business logic. You kind of want this permit module to stay like vanilla and clean, and have no OTP, gen server, or sort of like runtime concerns in it. It should just like express its constraints through rules and state transitions. This is just basic. It's the same thing as a list of atoms. So
It's
there's
the-
a million different ways to do def
It's
structs.
the A at the
Yeah.
end that makes it atoms.
Yeah.
Otherwise, it would be an array of strings.
Words, W is
Where
for
the words are
words.
separated by one space.
Too many, there's too many structs.
Yeah, and I'm pulling this out from like a different project as fast as I can, and this is faster than doing a list and then doing the atoms and the commas. So that's why.
The cool thing
No,
about
otherwise, it's arbitrary.
the cool thing about these sigils is that you don't have to use parens. You can use like curlies or like angle brackets or like whatever you need to like. If you were doing strings, like if you were using tilde s and you needed to be putting like parens in there, then you could start it off with curlies instead, so that you could use parens. But if you needed greater than less than signs, then you could start it with some other obscure symbol. Like it almost lets you start it any way you want. They're really cool.
And I really like using them for like required parameters in some kind of an ecto schema. So you don't have to. It's really easy to change, modify, or add some kind of like optional parameters, and just do the sort of plus down here. Okay. So now I need to get back on track. Okay. So where were we? So so now I just wanted to point out like that all like the way we're expressing the business logic and we're enforcing the constraints is we have a pure functional module. We're pushing it through some rules. We're going through some state transitions, and we have to hold some kind of a state. And we're modeling our state as just a generic struct, and then we're keeping our commands serialized through the Genserver. So that we don't want to have we need the messages to go in order, and a Genserver has a mailbox which is just a first in first out queue, and so it'll always keep like the messages in order. And so you can use a Genserver anytime you kind of need those sort of constraints. We're publishing some side effects. So we're publishing an event, and all of these events are pretty much just saying from our permit, we're going to grab the stuff we want, and then we're going to publish it over PubSub. And this more or less lets just having some kind of as long as our live view is connected to the same PubSub. I mean, if we go to like the other application, I have some sort of a messaging interface, and it just wraps the default Phoenix PubSub in pretty much the same exact API. So this is just going to let us tell anybody who wants to listen a permit has been rejected or submitted, and this is helpful because we're trying to in the actual real context, and this is going to be way too much information. Oh man. The worst thing is they make you go through this sign up page, and which is it? You're not sure like which account did I use to sign up? I think it's this one. Nope. Let's try this one.
So do you publicly announce it to publicly shame all permits that are rejected?
No, so
Display it on the live view of the.
in Solar, what we're really doing is we have this is getting into like client consulting material. Up here, somewhere over here. Okay. What we really have is this permitting workflow is inside a bunch of other things. And as these, so this is what we actually care about over here. And the things that we're getting permitted are these like designs, and what we want to do is we want to trigger some sort of interaction to happen in some different workflow, and the permit workflow itself shouldn't actually know any of that. And so that's what we're using. That's what we're using this, and that's why we use PubSub. So, and at least in my experience, pretty much everything where almost all like PubSub is just used everywhere, and so like different like maybe not using Phoenix PubSub directly, depending on like the messaging guarantees that you need. Like if you need like an ordering guarantee or like an at least once delivery, you might use like a different kind of solution. So this Genserver is just responsible for publishing out, and then we can trigger some side effect. And then if we have some other workflow, it might not be another Genserver. It can be triggered based off of the event. So if we need to do automated emails, that's basically an event handler. And then so like, do we have any questions? So like kind of like where I'm going with this, or what I kind of want to display, at least with this application, is like what almost every single business workflow kind of needs is like usually some kind of PubSub, some way to keep state, some way to have query, some way to some way to query some other thing, some way to implement persistence. And so like any thoughts, like do we have any questions about kind of like the overall scope of like what I'm trying to at least have in one place?
I'm just curious, you're doing this all like domain-driven design style?
Yeah.
Okay.
Yeah.
Cool.
Yeah, except I haven't said it yet.
Yeah.
Yeah. And okay, so let's see where we. And so like I've been working on a startup, and it's in solar, and I was basically going to build all of this, and I haven't had the time to get it done because it's a lot of work. And one thing I've been researching is how to have like sort of runtime changes to the business workflow, and and the reason for that is you might say we implemented our fancy permit state machine over here, and they want a new status, and then they want a type, and they want some new fields, and they want some new information on the permit. And every single time they want to change to it's just some trivial change to the business process. So, we hired a new person and they need something different. Whenever I have to make changes, I've got to basically make changes to the code. And so if I need to make changes to something like a business process that changes a lot, that has to go through a developer, and all the developers need to know, like at least in the case of this, like now we need a developer who knows OTP and Elixir and the conventions here, and that's like a lot I need to know. I mean, I've basically made this is like the cleanest possible Genserver OTP I could think of, and that I could do in like a day or two. And I think this is still a lot to swallow. Like, and you kind of have to know supervision. You got to know like why are we using a dynamic? There's a whole lot, and so where I'm going is that this permit module and the specification of this business workflow, the rules and these states should probably be in data, and they shouldn't really be in compiled code. So, and this is kind of an approach I've done. This is kind of where you start getting into like rule expert-based systems. So let's see if I can find my diagram again. And what most of these rule-based expert systems do is they model these business workflows as a graph. And so, let's see if I can get the zoom. Come on. There it goes. And so what we did with our permit module is we just have these rules. They say, can we do this? Yes, no. For our given state, can we do this? If yes, then okay, let's change our state. And so idea is we define the actual rules that we have in code, but we have some sort of a API to build a graph of the workflow specification in with outside of it. So and the reason that's interesting is because then the business can change the workflow themselves, and they don't have to pull me out of my basement, and I don't have to put pants on, and I can actually like, I can like leave them to it, and they can get in their own mess, and so, and I've done like a lot of work with Salesforce, and I've seen like some of these declarative tools where you kind of build a graph and you have a little process workflow diagram. There's like a whole lot of BPMN image. Like there's a lot of software solutions that then there's like specifications for modeling business notations, and at least as far as like the rule expert system, let me see if I can find a REIT graph. The algorithm that most people use under the hood for like highly performant, this one's okay, at least like highly performant like rule systems, is they'll use like an algorithm called REIT, which is a big complex like stateful algorithm, and it has some kind of a topology that looks like this, and it's doing this so that it can evaluate hundreds of thousands of these rules expressed by people who don't know how to code. So one place where you find like a lot of these rule expert systems is like airliners. Like since the 90s, they've been implementing these to say, well, if there's another airplane on the runway, we don't want another airplane to land at the same time, so that's a constraint, and so they express that in a rule. And then you take a lot of those rules like that, and then you multiply them by hundreds of thousands, and then for any given sort of situation that occurs, some sort of fact happens, some sort of a sensor, somebody pressed a button, then it has to run through all these rules. And what it's doing is it's basically saying, it's feeding, maybe I can pull up mine. So it's feeding at the top of the graph facts, and then it's outputting like reactions. And I guess what I'm kind of trying to express is that there's nothing in Elixir like this. There are some other libraries in like similar places like Clojure and F# that let you kind of build rule-based expert systems. And I've looked into them, and they have nothing like OTP. They're making like a lot of assumptions about your runtime. They kind of like force you to use Postgres or something like that. And this is like, and it's like something that has a lot of established use cases. And like I guess I want it in Elixir, and so I guess like the main takeaway from this is that this is kind of like, I think like the next, at least one of the next stages to like kind of how we kind of build one of these problems, or solve something like have something where the business process is changing dynamically, or in the case of solar where we have a different city, like a different utility company, and they express different constraints, and you need to be able to put those and not like you don't want a developer in that loop, because developers are expensive. Every time you have to make, like, maybe if you have the best CI pipeline, you can get it down in like 5 minutes. You've done every single Docker image optimization to squeeze out, and you can get a developer to push something in a master, and it takes 5 minutes. And that's still you had to pay that developer for 5 minutes, and that's that adds up. And then you also have to have all of that developers' experience and knowledge, and if they had to set up a CI like that, they're probably really expensive. So the main thing that businesses are looking for is a way to solve like these, they're trying to solve business problems. They're trying to have some kind of a business workflow expressed, and developers are trying to be lazier, and like it kind of baffles me whenever I see like business logic kind of like this expressed directly in code, and it's not some sort of a toy project. I mean, like there's definitely like use cases where, you know, you would have some sort of a business workflow like this, and it would be fine. But at least like in a sort of a big enterprise, or like a lot of the kind of things that I've worked with, it's not a strategically good idea to hard code business logic this concretely.
Have you looked at all into, I don't know if this is possible, but would something like GenStatum allow you to actually capture which transitions are allowed and stuff? Is that possible to capture it as data and pass it in? Since it's all callback based?
So the idea is that we express the constraints as a graph, and you know you have like if this, you have some rules that'll branch out, and you can go into different condition states, and like as facts move in, you kind of get different states.
Right.
And based off of that graph, you can have more or less any sort of process topology that works for it. So, and this is why I kind of wanted even more time than 3 months, but I wanted to have like a live demo of this, and it turns out it's extremely hard. And like I don't know if any of you have done like work with a graph library before. Like they're fun.
Just graph database.
Yeah. And like, and I've been exploring like, okay, what's the difference? How do we express? So, you know, do we have a step in each node? And then, you know, okay, do we have the rule constraints as the vertexes, the paths to each different node? And it really turns out that there's a million different ways to do, structure these graphs for the problem. And as far as I can tell, the only to kind of get these kind of constraints right, because you're bringing something into a highly dynamic runtime, and anybody who's played with Ruby a lot, like you kind of know how that turns out. Like it's there, you kind of have to like the sort of contracts that you have to enforce for what sort of functions that you're injecting. Actually, we can look at a toy version of what I'm that. At least as far as I've read on using this technique, I basically have to learn category theory and Haskell to like read these papers, and so it's not going to happen in my time.
I'm just wondering. I mean, I don't know a lot about a lot of those industries you mentioned, but the use cases I've seen, a lot of them I think just fit into like. I think a trained user could express it as a state machine graph,
Mm-hmm.
and it doesn't allow them to compose rules, or things like REAP does. I'm just wondering if there's like a good way to pare that problem down a little bit and say, oh, it's still like, the examples you were showing of like solar permit workflows,
Mm-hmm.
those all seemed like, okay, I could probably write up one of these as a state machine, any one, and I could get a few users to build all of them.
Mm-hmm.
But I don't know if there's just a good. I've also someone recently told me about X state or state X, I forget which one, but it's a slight extension of the specification around directed acyclic graphs,
Mm-hmm.
where you can basically have subgraphs, and it doesn't take a whole lot of extra work, but you can essentially start to compose state machines within one another, and I'm wondering if that's it.
Yeah.
It might be a cheaper way of trying to tackle that problem and still get you most of the flexibility.
Yeah, at least for my use case in Solar, I think you can express those constraints in something that's more concrete and not so like abstract. So like the abstract is like you're expressing things as rules, and they have to like match together and return a fact and things like that. But you could probably do some more like Solar specific things and make it work.
Yeah.
And I think at least for as far as like my time is concerned, I probably should have done that. But it's so much more interesting than me actually like, writing the.
If you want to learn tag theory, there's nothing
Yeah.
wrong with that.
And it's interesting for a few reasons, because like every time I've looked at like sort of like, so part of it is if you look at like Apache Beam or like Airflow or sort of all of these or TensorFlow, all of these that are different systems that have constraints where it's like changing at runtime. All of these are using DAGs. Apache Beam's peak collections are DAGs. TensorFlow graphs are they're DAGs. And all of them are expressing these computations as a graph so that they can compose them, and like there are like a lot of reasons for that. Is because you're taking the specification of the code, you're bringing it into the runtime, and you're making it portable. So if I wanted to, if I have some kind of graph and I'm feeding it facts, the specification is just data, so I just have to bring that into whatever process. If I want something that's guaranteed to complete, I'll spin up 4 processes and they'll all give me kind of the same answer. So I mean, like Nix, like a lot of build tools are also using graphs. At least like, and I'm trying to build a library, and I'm not going to show it to anybody because it's a mess. But one thing I'm trying to do is to hash the hash, like where the parent is is identified by the hash of its children.
Yeah.
And that's super useful because you can start introducing like determinism into it, where you say like has anybody seen what is it called? It's like a recent Strange Loop presentation where they're totally dropping it. It's like a new programming language that hashes each function definition immutably. What is it? Unison. Is it? Anybody heard of it? But it's this whole idea of hashing something with like a checksum as like, and then like putting it out like it's something that Joe Armstrong talked a lot about in his talks. And so like the Unison guys are kind of trying to building this from the ground up as like a language. And I don't really know if we need to build a new like Haskell like programming language to do this. I think we could just express this computation as a graph. And what's nice is like if say we made this permitting workflow and we define, you wrote it and you want to share it. How are you going to share it? Well, if I have code, I have to like share it as code, and then they have to like learn how to deploy Phoenix and all of this. And so, but if you just have the bare specification of just the state machine, you can it's portable, it's data. You can kind of send it over, and then they can start using it. So the real problem I'm trying to solve is like how do I get something like these like Solr workflows, and how do I just turn it into data so that I don't have to like write all of this OTP for each workflow. I mean, I could use something like commanded, and we could go all in on like CQRS, and commanded is nice because it does like a lot of this OTP for you. So you kind of define a commanded application, and you route messages. It's pretty much the same as what I did, but a little bit more abstract, where they have, maybe I can find the actual dependency. They have process behaviors for what an aggregate is. And if you're unfamiliar with like domain-driven design, an aggregate, basically just handles commands, returns events, and it can keep state. So like all of these are doing is like pretty much you can model any workflow as an accumulation of commands or events, and sometimes it has state. So what I think is that it's we're gonna like for some implementations of things, like either it's commanded or OTP, if we're like hard coding some of these business workflows that have dynamic constraints, it's gonna be like we might be better off like modeling that as data too. So it's the same thing we're doing in like the flow library, and it's like flow just defines makes this like flow definition, and then he builds like a gen stage topology that's optimized based off of that. So, and I'm pretty sure we could do the same thing with just business logic, is take the same kind of concept of pulling things out and then generating workflows off of this. And is like anybody seen like Dave Thomas's like most recent talk? But he goes into Prolog, and Prolog more or less uses kind of the same approach, except it's like a backwards chaining graph. Like that's pretty much all of Prolog is. You put in like rules and you pass in facts, and it'll like figure it out based off of it. But it's, I don't know. That's I've more or less like spent all of my savings, researching this instead of making something useful. So I find it super cool. So if anybody wants to talk about it. And that's mostly what I have to say, is that all business workflows are accumulations of facts, and facts, commands and events, if you want to use like domain-driven design terminology. And we can pretty much build all of these workflows that we're doing in Elixir, and we can pull them out as data if we want to get fancy with category theory. So, and that's it.
Awesome.
Cool.